This is the simple abatement model we're going to implement using OO programming. Um, this is the water tank control part that has three components, two valves, and one water drain pump. And in the combustion part that have two valves, one is a pilot valve and the other one is a fuel gas valve. And yeah, so yeah, that is a very simple abatement model. So yeah, that is be good example to understand how the OO programming working. And this is the hierarchy diagram for that. Yeah, a water train have has three components, and burner it has two components, and abatement owns two control models on there.
We haven't created a pumps model. It is completely the same with the valves model. The differences are only named. Commands and state name. States are stop and running. Commands are start and stop. Now I'm going to create a new function block for C pump. POU C pump. C should be capital. Okay. Yeah, need to create a state machine as usual. A state machine folder. So why I'm making folder is just to manage it easily. State machine SFC. Creating methods for start and stop. Now I'm going to create a variable for command. Yeah, all the command is defined in enum lists. Okay. But we don't have close and start, not close, start and stop command. So I need to add a start and stop command on the enum list. Okay, that's the form. Now back to start, and yeah, start variable appears, and stop also need to make assembly. Yes. So it's time to make a state machine. The form is completely same as the valves. So it's time to give a state name for first one is just stopped, second one is running. And the transition condition is command name. So first we got command from start. Okay, and next running to stop is we need to command for stop. Okay, the state need to change it to the stop state. So yeah, the state machine is completely completed. So and then we need to add state machine variables running. Okay, now two state machine variables are created. Now it's time to create a widget, the visualization widget. First, that is stopped variable need to matches, and second one also running, and name the display title I'm going to change it to be matched with real state name running. Okay, and the command name also need to be changed to the start and stop. We're done. It appears the start and next one, and then it also appears as a stop. Okay, in visualization we need to add pump and remove all others. The name has been changed. I'm going to rename it C pump, and it automatically renames everything. Yeah, very good. Refactoring system in CodeSys. Okay, we need to run my pump in the main. Oh, I haven't created main method. In the main method, the first thing we have to do is always a running state machine. Forget, yeah, don't forget, yeah, running main and state machine. That's the execution chain. Okay, my pump. There is my pump. Okay, the pump widget, yeah, runs my pump, running the system. Pump on visualization. If I give a start, it changes to running, stop, and stopped. Yeah, that works as I expectedly. So under the water tank, there is two valves and one pump, and yeah, we're going to create the hierarchy in the water tank. The name is water train, but is treated as a water control. And the state machine, it has a for command the start and stop and drain fill stop devices. The drain command makes a drain valve open and fill valve close and water pump start and fill valve otherwise. And stop devices close all valves and stop water train. So now I'm going to create a new function block for water tank simulator. Name is water tank controller. And need to add a sub component. One is fill valve, and the type is a C valve, and the other one is drain valve. That also the type is a C valve, and the last one is water pump. The type is a C pump. Okay, we have added all the child component. But the problem in the C valve is we don't know what valve is fill valve and what valve is drain valve. We have two instances, but inside of the C valve it is difficult to recognize and distinguish each valve. So I'm going to give us some identification inside of the C valve. So that is ID. Yeah, the type is a string. Add the str ID. Then this time I'm going to create a constructor. FV init is the preserved function name, method name that executes only one time when the instance is initialized when it creations. So I'm going to give ID as an input variable. It takes when it creation and it overrides to the strId if that is a local variable and input variable. Yeah. So we need to give some initialization value not to have an empty string with empty string, and in device application level we can give a identification for each feedback and C valve. So there are number of valves we have created before, so I'm going to remove all of them. So now I'm going to give identification that is a fill valve. I'm going to write now fill valve, and that is drain valve. can give a drain valve. So the string value, will have that valve identification when it creation. And we need to run water tank controller. The type is C water controller. Water tank control. So we need to run that water tank controls main in the main task. Okay, we only have one water tank control, and we need to run valves main in the water tank controls main and valve and fill valve and there is a pump. We need to run water tank, water pump as well. So all the child components just main should be run in the upper higher Rockies component is main. So now we need to implement the method drain and fill and stop device method in the drain. Opens drain valve we have already implemented before. So that is part of the C valve. So drain valve opens drain valve and water tank, water pump start, and fill valve they should close when drains water. And fill, vice versa. Drain valve close. And water pump should stop. And fill valve open. So we have created two control methods, and I'm going to create a state machine. We have a omitted stop devices method we will be added later on. State machines actions. Okay, this state machine is just a bare, and in the main the state machine is calling, and I'm going to extend the widget, the C valves widget to know what valve it is by showing the identification value. So there is a ID, it's a string type. Okay, the visualization on the screen has been updated. So we can let it know that is a drain valve first, and we have one more same type of a C valve. They're going to be fill valve. So in there, I'm going to match it as a fill valve. Water controller, there is a fill valve. All right. Okay, what we have to do, two same type valve and two different valve. That indicates the different instance. So I think we also need water controllers widget that have a drain, start, drain, fill, start and stop. This time I just added only two commands, and we're going to match this water tank control instance directly. And when it marks down, yeah, that requires need to execute train command. And second one, filling, actually that is fill, and also same things, repeat the same things, and execute code and fill method, fill command. Okay, and the visualizations, what tank control. Okay, okay. So yeah, it's quite bigger than the others. Yeah, resize it. Okay. It has two command. So yeah, let's check drain and fill working correctly. Also wanted to show pump as well, because yeah, there are total three child component. Okay, run the system again, download it, and visualization is turning on. And once it fills and drain valve closed and fill valve open, drain method makes the drain valve open, fill valve closed. Okay, that is working perfectly.
This is the water tank controls state diagram. So it has two state and uh, two method to the water tank controls, and it has three more method to control the sub devices: drain, fill, which already implemented, and stop all devices when it devices when it calls when the entry to the stop state, and when it running, so it repeat the drain and fills depending on the water level. So we're going to implement the state diagram. So this is water tanker's state machine. So we're going to add transition conditions in between here. This should be stopped. This should be running, and this also should have a command. And the command is command list. Start, stop, and jump back to the stop state. Okay, and we need to implement the action method. The first action method is just stop devices. Stop devices, we haven't implemented it. So I'm going to add stop device. Okay. Close, close, stop. Okay, and we need to add a start and stop. It can copy from this. Okay, start and stop. We have created it. So from the outside, yeah, we can call the stop and stop. Okay, in the main, I think we need to create give yeah, some conditions for in the action. So in the learning action, so the way we are making the is we give running main. This means in the learning state is and main action function. It should be ST. In the mains, you can give subcomponent a running main. So running main will execute every cycle. So we're going to add one more. And execute stop devices in the method. Stop entry. Okay. According to the diagrams, above the 70%, it drains water. So we need to measure water level. The water level is little. We can give like that. If the water level is higher than 70%, then we can give a drain. We can make a drain. Otherwise, under 20, we can fill the water, right? Lower than 20%.
This is the water tanks simulators state machines. It has a total of 3 different state: idle, draining, and filling. When drain valve is opened, it drains the water level and lower than 20%, and fill valve is opened, it fills water up to the water level is 70%.
We can give one more class. So water level simulator. And this time, yeah, level field. And we also create a state machine for simulator. And gonna make a main, but this time I give input. That'll be input drain variable state. Fill variable state. Okay, and it returns water level. Okay, and in the state machine, okay, training. And idle transition condition is training transition condition is training valve is opened and fill valve is closed. Vice versa, for filling valve, fill valve is opened and drain valve is closed. And let it fill the level 20%. This is 70%. Back to idle. So something change it to the higher than 70%. I just found it bug. I think actions should be a method. This is a filling, more slower than the training. Training should be faster than the filling. Now this vector will be adjusted later on. We will see the speed. This is training. Okay, we have completed creating an action method, and we need to run state machine in the main. So I'm creating state machine. All right. Okay, and water level simulator is here. Water tank control should have a water level simulator. Then we can execute main in the water tank control main. We can execute it, but there is a two state. Open the state that we need, and the fill valve. Second one is a fill valve. Open the state as an input. Okay, and all water level we can out to the all water level. So this will also execute simultaneously, and we will see how it working. And then we need to put a state machine for water controller as well. Take from here, copy to the okay. The variable color variable are same. Okay, this is water tank controllers a state machine diagram, so we can execute it. Okay, and the scale and bottom to top. Okay, this is a water level KZ. Okay, okay, see the visualizations. Start. Okay, water level is increasing. Then water level is decreasing, and water level is increasing. Yeah, in the learning state, and it repeats drain and fill actions. And once it's stopped, our state is in stop. All the equipment, the devices are stopped. So when the stop actions is executed. Start again. It's perfectly working that I expected. It suit my expectation.
This is a fuel gas burners state machine. There are three different states, and each state have one transition conditions. And in the ignition state, it opens a fire valve. If a flame is ignited, it closes a fire valve and opens a fuel gas valve. And the state machine goes to stop state, it closes the fuel gas valve. It is a very simple burner model. So I'm going to create a fuel gas burners class as usual. That should be a function block type, fuel gas burner. Okay, in the variable that have, not variable as a subcomponent that have file valve and the ID should be file valve. But this, yeah, I'm thinking that it would be good if the file valve will use as a delay valve. The fuel gas valve, fuel valve is a fuel valve. And yeah, that requires also state machine. I'm adding state machine as a user. That is a very, I think now you will notice the state machine is a very structural. So yeah, three state machines, state and transition conditions in between the state machine. The first, start ignition lit. So give a name to them. SD stopped and ignitions and lit. So yeah, we got three different state, and we have a flame check flag. Actually, that is a feedback that requires some kind of simulator. This time I'm going to use as a bool, and by button clicking on the visualization. And yeah, we can copy start and stop method from pump because we're going to use the same command. So if we declare a command, that works. Okay, we need to run the file valve main and fuel gas valves main in here in the main. This is kind of the rule, to run our sub component. So fuel gas banner look after two valves, and now we need to implement transitions. So the stop to ignition is just a start command, so we can put some transition condition as usual. The enum command list. Let's start, and we need to add where to go from lit to stopped. Okay, and need to add more transition conditions. That should be stopped and that should be flame on feedback. So boolean flame on, that's it, and we have completed the stated transition conditions. So we need to add the action method for each state. So I'm going to add the action for ignition entry, and in the ignition entry we need to open the file valve, and lit also should have entry, lit entry, And in the read entry, we need to close file valve and open fuel gas valve. Yeah, that should be fuel valve. Okay. Yeah, now I'm fixing to the C delayed valve instead of the C valve. Now we need to implement the last action method, that is for lead exit. The lead exit, we need to close fuel gas valve. That's it. And all the action method needed to register into the state machine. So in the sub object, the ignition entry and main end lead entry and lead exit. Okay, this is the all the action method that we need to allocate. So now I'm going to create a fuel gas bonus visualization wizard. As a user, I'm adding state machine, ignition state, and we have one more state that is a lead state. Okay. Fuel gas burner also start and stop command. So locate it, place 2 buttons on there. Give an input variable, that is placeholder, and give a color, collect the state variable, that is ignition. The X means the state is activated. The other one is lead. Okay, give a group box and name is a fuel gas burner. To recognize what this is. Okay, we need to add fuel gas burner in the main as a element. Fuel gas burner, C, fuel gas burner. And need to execute main as well. Okay, that's it. And back to the visualization. Place the fuel gas burner and you can find the instance in there, fuel gas burner. Alright. Place the fuel gas burner to the right place. Okay, not only fuel gas burner, we need to place a valve wizard as well. So I'm going to place delay valve for the pilot valve. Okay, place it here. And before we need to run our fuel gas burner, I recognize that we required flame simulator. So I'm going to create a flame simulator method in the fuel gas burner. Flame simulator is here, so we have to implement the method body. So if conditioner, so if it lasts in ignition condition then 3 seconds, we are going to give a feedback. The flame on will be true, and the other, if we have stop state, is the stop, and the flame going to be false. So it is completed. So the only thing is we need to execute to the flame simulator in the main. So that shouldn't be called outside, so I'm going to give a private property. So now everything is fine. We can run our software and make it online. Okay, our visualization is coming. Start the fuel gas burner. Yeah, 3 seconds. The fire valve is in opening. Now once you finish it, yeah, fuel gas valve is opened and the fuel gas burner state goes to lit. If I go make it stop, the fuel gas valve closed and fuel gas burner state also goes to stopped. And once it again opening, 3 seconds, fuel gas valve opened and burner goes to lit. And after 3 seconds later, fuel gas valve stopped. That also can be controlled by individually as well. Okay. So now fuel gas burner is also working as a perfectly that I expected.
Now I'm going to, we are in the final stage. We're going to implement the abatements, simple abatements state machines. That state machine, this time I'm going to use USC chart, a US chart. That means UML state chart. And that is supporting full uh, requirement of the state machine officially, instead of the SFC chart. So this is a diagram of the state machines and stopped, running, stop, alarm state, and each state have some action method. So we're going to implement the action method of following this concept. And these are the transition condition in between the states. So yeah, let's jump into the code. Okay, this is the code we have implemented last year, and for that I have bring my a class to use a USD chart that is a part of the infrastructure. So you don't need to create yourself. You can just use if you use infrastructure. Okay, I'm going to create function block, and that is the abatement. And that also, that is a typical step. We need to create state machines, and we need to require main and the state machines in the USC. There is a UML state chart you can see on there, and state machine, same structure, same concept. Right? Okay, so now we can use the state machine using here. Okay, implemented the state machines using this. Start state, we need a state, and we need more state, the form is like this, and this is transition conditions with the transit from here to here, here to here, here to here, here to here, here. Yeah, we can give a name for each state. The first one was stopped learning. Give a name with the same format, and the name st. Okay, that is a state, and we need to create a state. So actually, we don't need to create a status variable, but if we use the internal variable to state variable state machines, so we have to create the state variables. Stopped. that variable type is yes, state for each state. Same variable type. Okay. Okay, we have state machines on there, and we have to give this is exit entry, entry to exit, entry, exit. You can give entry method key. Inside of this stop and entry and exit, we're going to execute the method. We have to execute the method in the stop, and there is a entry state. Oh, entry. So repeat this for all state. If you want to know the time, elapsed time, this is a stamping time for. And yeah, we give all same things. Entry state, and in the exit, we need to call exit state. Okay, we have done that.
Okay, we should allocate our action method. The actions appears here, so we can choose stopped entry here.
Stopped exit. Running entry. Why so?
Now we almost have done. That is the final actions in the our state. Okay. Now is the time to adding behaviors in the transition conditions and the behaviors in the actions as well.
Coming from the system conditions, but this time I'm going to use manually the b the lady this that also can be a object, but this time we are going to just use a simple bool alarm. All right, and the first transition condition is a start command and lady and alarm, so we need to start command. Same things, and we also need a start and stop method. Can copy from because of all method name. So start and stop we have, and then state machines. We can give a transition conditions. So if transition condition is too long, we can use a transitions here. The transitions we can use. So this is a stop to learning transition condition. So in here we can use it like this command start and be bloody and be not alarm. Okay, this is yeah, kind of the if condition, so that result should be true or false. So inside of the our transition, so we can use it directly here. It is much simpler and shorter form. And the other one is a stop command. That is a very simple, so we don't need to creations of transitions. Just a command list and stop. That's it. This is a very simple graphical languages, and the other ones. This a small number 2 or 1 is if both transition conditions are happened at the same time. So the which path will have a more priority. So alarm path will have a more priority than the stopping. Okay, so alarm is the alarm, right? Let's have a check. Yes, alarm is true, and alarm will be false. So not the alarm. And from here to here, yeah, the burner should be uh, not lit state, and water level and is lower than 20%. So this time also I'm going to create a new transition condition. So here stopping to stopped. Beep. We have in here we have object in burner controller and yeah, the hierarchy. See here, we have a burner and water trains. We can create it. In the main, we have created those two. Come on here, and we can create an abatement here. Allocated main. we have a water controller and fuel gas burner. So in the main, we need to run those two. And its own state machine as well. Run state machine myself. Okay. Fuel gas burner lit as the remember, yeah, it should be false. So not, and water level should be lower than 20%, and water and level be lower than 20. Okay. All right. Okay, we will see the layer on the other here, the state machines, and then transition condition is stopping to stopped. Okay. It is really simply possible to create our transition conditions. So I think, yeah, the remaining things are we have to implement inside of the actions entry, the stop actions, post entry, water train stopped. In the entry we have already created, so that entry machine stopped entry, water train, water controller, stop. And in the running entry we start the water. Start. Okay, that's it. And then in the main, it has a main and main action. So running main, we need to create it. What should do? We should monitor the water level and then um, running time. We can monitor water level 60% and the running time. So after 5 seconds should be after 5 seconds you can start burner. Uh, to get the running time, to elapse the time, we have to execute to the state running myself. Actually, SFC doesn't require to run itself, but to use class the USC, I made the USC state class. So we have added a state class for each state, and every entry in the entry we stamp the time, current time, and we execute the time in main. Then it calculated its time elapse. The main, it's elapsing time in here. It's a calculate its elapsing time. So we have to execute it in the main. Then we can get the time from the time variable. Here, running main that we required to add. Running main. So, And in the stopping, burn, we stop the burner and give a drain for the water. In the stopping entry, in here, this is actions, fuel, stop. We'll stop the flame and turn off the flame, and water drains. Drains water wherever it is. Okay, and the last one is in alarm state, and in the entry only burner stop and water stops, and which means all the equipment stops immediately. In the alarm entry, fuel stop and water stop. Both equipment are okay, both are stopped simultaneously. Okay, I think we have implemented all the conditions and then state machine using the USC chart, and then going to show the later on how the USC chart is working. And okay, for that now we need to create some visualization. But this moment our visualization for the abatement is very small space. Yeah, there is no space to locate it. So I'm going to add one more visualizations for the abatement. There is only one abatement, so we don't need to create. Okay, and we tools. Okay, we use tools usually. Usually, we use tools. Yeah, okay. And probably and then we'll select. Sorry. Variables. Main. Yeah. Fully able. I think there's a whole. I think we use it. We also use variable. It's all based on results and color. How much we and we don't. Sorry. Sorry. Video. What is video? Layout. Show. And it should be available. Awesome. Where is it? It should be. It is called. It is called. And this one. Can we repeat? Was. Okay. That is not. Can we repeat the space? Okay. Goes all water tank. These are equipment. So for the layout. This is what things me. Letters. Can you see everything on screen? Come on. Oops. Come here. Okay. Alright. Okay. Much better. Go like that. Okay, I made a very simple modification for the water trains and then abatement. Here I added a train when start water train start. That means what wherever water level is, it is trains first and start and then fill again. So water level is empty or high or middle, yeah, will start train first. If the state is not ready and if there is an alarm, I'm going to reject comment. So only allowed to in ready and alarm we can make a start comment. So in the actually in here it's learning entry and the start entry transition conditions that stopped it running. Those two conditions are not required. Only this transition condition is yeah, possible to run. But yeah, I just stay in. Okay, I'm going to run the software and show you how it works. And I made our visualization to reorganize the positions and the widgets to smaller than before because I would like to see all the controls component and object in the one screen, and then I'd like to want to show all the state for each component. So if I I'll start to run the software. I'm going to make a start. If I make a start without a ready, the command will be reject. System won't start. So if I wanted to start the system, I have to make a ready and then start. System is already, and water and pilot bulb will be opened a few seconds later. Okay, now ignition start. Then fuel gas is opened. Now system is fully running. The fuel drain is repeat again, and if I'm gonna make the system stopped. Drain first, drain later, and stop the system. And yes, water tank is drained and fuel gas are stopped. Burner also stopped and valves are stopped. And once again, I'm going to show it again. Start it again. Okay, everything is working as I expected. Stop it. Burner stopped first, then once our level is 20% under 20%, system is just stopped. And then I'm going to show you alarm state. Okay, start again. Make the system running. Pure gas burner is stopped. Opening ignitions. Okay, and alarm. Everything stopped immediately. If I reset alarm, system state back to the stopped state. And if I start it again and the water level is in between the 20% and 70%, it drains first. Then system is operated again. So this is a definitely show how the state machines and how each object collaborated into one system. I think this is a very good example to understand the state machine and object-oriented programming, OO programming. Okay. Thank you for watching. I'm gonna give you this software as an example programming, and you can practice yourself and then following my video, and you can practice yourself from the scratch.